All right, guys, I wanted to do a few more examples, and there weren't any more. So I'm just going to go ahead and do one of your homework problems with you. It's number 5 in the homework packet. By the way, there were some stickers that go along with this activity. There's a stack of them outside with all the other packets, but if you do not want to use them, it is absolutely fine. I would just say just go ahead and write in the reasons. But they're out there if you wanted to get those as well. All right, so let's go ahead and look at this nice, lovely problem. First of all, they've told us that the measure of angle 1 is equal to the measure of angle 3. So I'm going to go ahead and say those measures are equal. They're congruent. We might have to prove that later, but they are equal. We also know that the measure of 1 is equal to the measure of 2. So this angle right here is equal to, let's do 2 ticks to that one right there. And we're trying to prove that 3 and 4 are going to be congruent. So let's look really quickly at this one. So the measure of 1 is equal to the measure of 3. Measure of angle 1 right here is equal to the measure of 3. That is our given. Okay, why would 1 be congruent to angle 3? And yes, it's so hard to teach with you guys not here to answer my questions. But remember, if measures are equal, angles are congruent. That's our definition of congruence right there. Those angles are congruent since their measures are equal. Okay, why then would DE be parallel to BC? So look, here's DE. I'm going to kind of draw this line right through there. Here's BE. So far, all they've talked about is 1 and 2. So when you look at 1 and 2, those lie on this transversal. Can you see that there? We've got one that's on top of this line. This one's on top of that line. So they're not interior. They're not both exterior, but they are corresponding angles. Okay, so since those two angles are congruent, then we have a converse theorem that says that corresponding angles are congruent, then the lines are parallel. So corresponding angle converse is what I'm going to write right there. They always have to be converses if you're trying to prove lines are parallel. All right, now back here, we know that measure of 1 is equal to the measure of 2. That was one of our givens. So why would 1 be congruent to 2? Very good, class. That is the definition of congruence. All right, now look what they did. They are now saying that 2 is congruent to 3. Well, look what we know about 2 and 3, first of all. So 3 right here is congruent to 1, okay? Also, 2 right here is congruent to 1. They're both congruent to angle 1. Therefore, and yes, you're right again, the transitive property gives us that 2 is going to be congruent to angle 3. All right, why would 2 be congruent to 4? Notice we've never seen angle 4 before. Angle 4 hasn't shown up in any of our statements so far. So this is where you probably want to look at your picture right here. Look up here at the picture and look at this, the relationship between 2 and 4 right there. Notice one of the steps previous up here was that we proved that these two lines are parallel. So these lines right now are parallel. So we can use any of our parallel line theorems to prove stuff about those angles. So notice what kind of angles are angles 2 and 4? Well, they as well are corresponding angles. It's not the converse this time. It's just the corresponding angle theorem that says if you've got parallel lines, which we knew from step 3 up here, and then the corresponding angles are congruent. All right, now they're wanting us to prove that 3 is congruent to 4. Notice again in your proof, here's 3, here's 4. They are both congruent to angle 2. So this is another transitive property that allows us to say that that is true. And therefore, why would the measure of 3 be equal to the measure of 4? Well, that is our definition of congruence right there. All right. Any questions? Just put them in the discussion and I can try and answer them.